Hi, welcome back. So this is 7.1 part 2. We are still talking about radicals expressions. So something to review. Remember that the square root of a positive number can actually have two square roots, because a positive 5 times 5 would give you 25, and negative 5 times a negative 5 would give you 25. So because that is true, that's important to remember with the next part. Because we don't know what this number is, the x squared, would we take it out of the radical sign? It becomes just the x, but we put the absolute value bars around it. That means that this number could be like a negative 5, or maybe it is a positive 5, but because we don't know the value, we use the absolute value bars. Okay? All right. Let's go ahead and look at example 1. So if we needed to simplify the square root of 2x plus 1 squared. Okay, so it's saying it's squared, so therefore the square root is going to be this number that's in the parentheses. So we take that out. Because we don't know if the square root is going to be negative or positive, we use the absolute value bars. Okay? All right, so let's look at example 2. It's asking us to simplify 16x squared. Whoops. So 16x squared, square root of 16 is 4. The square root of x would just be x. Because we don't know the value of x, we use our absolute value bars. You could also write this 4 and then just have the x in the absolute value. That's because once we find once we find the square root of 16, it's going to be 4, which is positive. So it doesn't have to be in the absolute value. The x needs to be because we don't know the value of the x. All right, let's look at example 3. We need to simplify x to the 6th, the square root of x to the 6th. And so we're assuming that the variable can represent any real number, which means it could be negative. So the square root of an exponent that's even is going to be half of whatever it is. And so if you think about this, the reason for that would be, this is what x to the 6th looks like that. So the square root of it is just going to be half of those. So then it would be x cubed. And again, because we don't know if the value of the x is positive or negative, we put the answer inside the absolute value bars. So we're dividing by 2 to find the root of variables. Okay, so the next one, we've got x squared plus 10x plus 25. So this is definitely a trinomial. We have an x squared, and then we also have an x, and then we have a number without an x. So that definitely looks like a trinomial, which means we need to factor it. So by factoring it, we would get x plus 5, and then x plus 5 again. So we could simplify that and just say x plus 1/5 squared. So the square root of x plus 5 squared would equal x plus 5. We don't know the value of the x plus 5, so we leave it inside the absolute value bars. And I didn't read the directions that I typed. Sorry for this one. I forgot that I did this one differently. Sorry. So the directions actually say, assume that the expression being squared is non-negative. And so that means the answer is either going to be 0 or a positive number. And so with that being said, because we know that it's not going to be a negative number, then we don't need the absolute value bars, and the answer would just be x plus 5. Okay, I'll try to read more carefully. All right, let's look at example 5. So example 5, we have the square root of x with an exponent of 14. And I'm looking at the answer that I wrote for this one. And so I'm not going to write this one on the board. I'm just going to read it with you since I gave you the answer already. For number 5, we're also following the rule that we're assuming that the expression being squared is non-negative. And so x to the 14th, again, if you divide that by 2, you get 7. And so it would just be x to the 7th. For your homework, as you're working that, be sure to read the directions carefully, because some of them will say, assume that the expression being squared is non-negative, which is why I wrote that. And then many of them will want you to find the absolute value as the answer. And for those, it's going to say, assume that the variable can represent any number. All right, so let's look at the now your turn. So while I'm writing it up on the board, go ahead and work that one out. And hopefully you got the absolute value, x plus 2. And go ahead and look at number 2. So remember, with this one, we divide the exponent by 2. So we get x to the 5th. And again, we're assuming that the variable can represent any real number, and so we leave it in the absolute value bars. And go ahead and do number 3. It looks like you're going to do some factoring on that one. So our final answer is x plus 2, and it's the absolute value of x plus 2. So don't forget your absolute value bars. All right, and then the last one, number 4, says simplify, assume that the expression being squared is non-negative. And so you should have gotten x to the 9th, and you do not need the absolute value bars on that one. Okay, so the next part is 7.1. 7.1 contains a lot of different ideas with radicals and radicands. The next part is a cubed root. And so for the cubed root, you're going to need a different calculator than just the basic calculators. So of course you have your phones with you, and if you don't have a calculator on your phone, you should add the app, because it'll be really tough to do some of these problems without having the benefit of a more sophisticated calculator. If you have a better calculator than this that has cubed roots and maybe roots to the 4, then you can also use those. You're going to have to play with your calculators a little bit, because not all calculators are the same, and not all phone calculators are going to be exactly the same. If you need some personal help with this, maybe I can help you either at FaceTime, or if you want to schedule just a Zoom meeting with just me. Okay, cubed roots. Each real number has only one cubed root. So first of all, if it's a cubed root, you're going to have a little 3 right there hanging out on the radical sign. And so the cubed root of a positive 8 is going to be 2 times 2 times 2. And so it's equal to 2. Now, if that cubed root was negative, then your answer is going to be a negative 2. Okay? All right, let's look at the next example. We've got a cubed root, and we have 343. So we've got a negative 343 cubed root. See if you can find the answer to that without looking at your answer. And hopefully you found that it's equal to a negative 7. Also, I'm sure you've already noticed this, that we've got a negative 8 and a negative 3. The difference is we're talking about cubed roots. We're not talking about a square root. So remember, with a square root, we don't have negatives inside the radicand. But with a cubed root, you can, because you can actually find the root of that, and it could be a negative number. All right, so let's go ahead and look at example 1. It says find the indicated function value. So we've got f of g is equal to the cubed root of g, and f is equal to 216. So that means we would just put the 216 inside the radical. Remember that it's cubed. And so using your calculator, see if you can come up with the 6 for an answer. Okay. And then example 2, we have x squared minus 50. And again, we're finding the cubed root. And so g is equal to 7. This is another function. And so if g is equal to 7, that means we're squaring the 7. 7 times 7 is 49. 49 minus 50 is a negative 1. So we're looking for the cubed root of a negative 1, which would just be equal to a negative 1. All right, let's go ahead and look at example 3, which we have a negative 27 x to the third. So the cubed root of a negative 27 is a negative 3. The root of x cubed is just an x, and so that's why the example shows that you have a negative 3x as your root. All right, so now you have some you-try-its. So let's go ahead and do number 1. I'll give you a second or two while I'm writing it up on the board. And again, this one is a function, of course. And so did you get a positive 5? Okay, good. So let's look at you try it too. And again, you can work it out while I'm writing it on the board. And did you come up with a negative 3 for that one? Okay. And go ahead and you try it 3. For this one, you have to cube both the 8 and the x cubed. And hopefully you got a negative 2x. Okay, so these aren't too bad. I was a little bit worried I couldn't remember what numbers I wrote. I was afraid I might have had such large numbers that I was going to need a calculator, which I don't have handy. Okay, so the next part, and again, this is still 7.1, is called odd and even nth roots. So the nth, this n represents an unknown number. We don't know what the number is, so they use that n. And then nth actually means like to what is the index going to be. And actually, I don't think I gave you that term, index. Maybe it comes up. It does. It comes up in the first sentence. So the expression a to the nth is equal to a denotes the principal nth root. The n is called the index. And so when we were having a 3 here, or if you had a 2, that's called the index. Okay, if n is a positive odd integer, then a n as the radical to the nth is going to equal to a. And if n is a positive even integer, then see how we need to use the absolute value, because it could be a positive or a negative whenever you have an even integer inside the radical sign. When the nth root is odd, it will have only one root. It could be positive, it could be negative, but it'll just be 1. When the nth root is even, it will have one positive root and one negative root. Okay, so study those examples, and I'm going to give you a minute just to look at them. Okay, so example 1, we had the radical sign, and inside the radical we had the radicand of x minus 2 to the 11th power. And the index was 11. It's an odd number, and so the answer would just be x minus 2. And then if you look at example 2, again we have an index of 7, which is also an odd number. And so when we're looking for the root of a negative 128, it's equal to a negative 2. Just one answer, because the radicand was negative. When it's an odd root, like a 7 is an odd number, the index, then our answer is going to be negative. All right, so example 3, we have an even radicand, or sorry, an even index I made that ginormous. There we go. And we have a negative 16 as our radicand. So this is an even number. This is a negative radicand, which can't be done. You can't solve this. So remember that negative numbers do not have real nth roots when n is even. 4 is an even number. So this cannot be simplified. And so you could just say not a real number for your solution. It's pretty sloppy, sorry about that. Okay, example 4. So this time we have a positive radicand, we have an even index, we're assuming that the variable can represent any real number, and so 2 is the root, and then x to the 4, the root would just be an x. We use our absolute values after we solve it because this could be any real number. Okay, let's look at number 5. This one is another function. It says determine the domain of f if f is equal to 3 minus 2x. Again, the radical has an index of 4, which is an even number. I just make those too ginormous. Here we go, 3 minus 2x. So in this case, what we're going to be doing is we're going to take the 3 minus 2x out of the radical sign, and we're actually going to solve it for 0. Okay? And so when we're doing this, we would just take away the 3. So a negative 2x is greater than or equal to a negative 3, and then we divide by that negative 2. So x, our sign flips because we just divided by a negative 2. A negative divided by a negative is a positive. And so our answer is going to be x is less than or equal to 3/2. And then you can also look how this function is written in set builder notation and interval notation. So the domain of f for all possible answers x is less than or equal to 3/2. And then with interval notation, we just needed the negative infinity sign, the 3/2, and then the bracket. One thing that I'd like to say about the first notation, the set builder notation that's on your handout, for some reason my computer just kept wanting to write 2 parentheses, and so after about 5 minutes I gave up and I just let it be. So you don't need 2 parentheses there, you really just need 1, but it's for some reason it just did that. Okay. All right, so now let's try the U-try-its. And again, go ahead and start, and I'll write it up on the board and then work it out. Okay, so our index is 7, which is an odd number. That means we don't need the absolute values. Because there's a 7 here, our answer is just 2x plus 1. Okay, U-try-it 2, we have a negative sign. outside of the radical. We have a 32 inside, and we've got to the 5th. And so let's see. The 5th root of a 32 is going to be a 2, because 2 times 2 times 2 times 2 times 2 is 32. Because we have a negative sign outside, our final answer is a negative 2. All right, let's go ahead and look at You Try It 3, where we have a negative 64. And then our index is a 6. So the 6 is an even number. We have a negative number inside the radicand. Whoops, I wrote it down completely wrong. Sorry about that. We have a negative 64 inside the radicand. So because the index is even, this is one that can't be solved. Oops. All right, and now let's look at number 4. And again, go ahead and solve it while I erase the board. And you can go ahead and do number 5, because it's taken me a little while to write these down. Okay, so to the 4th, so 3 times 3 times 3 times 3 is equal to 81. So the root would be 3, then the variable root would just be 1x. We've got a negative sign outside of the radical. And so to do this one properly, we really need our absolute values, because we don't know the value of x, and then we would just put the negative in front of it. So once we figure out what that x's value is, then we would be able to distribute the negative, but we don't want to do that before. Okay, and number 5. So f of x is equal to, maybe I should erase that solution. We've got 6, and then we have I just realized I didn't write down a value for f of x. So we can't do 6. We could, let's just say it was 2. So let's say f is 2, and I really don't remember what it initially was. So we have a 6, and then we have 3x minus 7. So 3 times 2 minus 7. So we have 6 minus 7, which would equal to a negative 1. So then we'd have a negative 1. 6 is an even number. A negative 1 inside the radical sign can't happen with an even number. So this would be no solution again. Okay, good. All right, I think that's the last one of part 2. And again, 7.1 has one other section. So if you'd like, you can stop the videos now and work on a little bit of the homework and then come back and do the last part. Or you can just stop the video now and start the next one. Okay, see you later.